Hi, welcome to our Java project. This project made by Azarya and Slil Korman. In this project we made 3D maze game using different algorithms to generate the maze and solve the problem. Now we will talk about the A-star algorithm we use to solve the maze problem.
A-star uses a best-first search and finds a least cost path from a given initial node to one goal node. As A-star traverses the graph, it builds up a tree of partial paths. The leaves of this tree are stored in a priority queue that orders the leaf nodes by a cost function, which combines a heuristic estimate of the cost to reach a goal and the distance traveled from the initial node. Specifically, the cost function is marked in red here. The Gn is known cost of getting from initial node to n. This value is tracked by the algorithms. Age of n is a heuristic estimate of the cost to get from n to any goal node. For the algorithms to find the actual shortest path, the heuristic function must be admissible, meaning that it never overestimates the actual cost to get to the nearest goal node. The heuristics function is problem specific and must be provided by the user of the algorithm.
Here we can see two different kinds of A-star algorithm, one with a heuristic and one without a heuristic. You can see the difference between them. Okay, now we will see an example of our project. First we will start the server over here. We can see a CLI menu that just opened. We will start the server. We can see that the server is on and listening on port 7070 over here. We will start two clients too. Just fill the properties over here. GUI property, 6 pool size, generator DFS, the local IP, 7070 for the server, and we will choose a Manhattan A-star. Okay, this is the window of our maze. Let's generate a new maze with 3 floors. Let's call it AAA, for example. Columns 22, 32. Let's do it hard. Here we can see the Super Mario character in our maze. We can move the Super Mario character with the arrows. We can go up and down from the 4 floors over here. You can see that the Super Mario moves from floor to floor. Let's open another client. When we will hit the help me button, the server will answer us with a solution. So let's fill again the properties over here. Let's do it 8. Generator DFS. Again the local IP, and let's choose BFS, for example. Again we have this generate screen. Let's do it with 1 floor. Maze name BBB and 32. Okay, it displayed the maze. It looks a bit harder. Okay, now when we will hit the help me button, we will see the solution. A pop-up just you can see the pop-up on the screen. When the character will move, you can see all the mushrooms from the Super Mario game that will take us to the solution. Okay, we can go to the solution just like that, do it fast. Okay, and we win the game. Now if we will hit let's solve this maze too. We will hit the help me button again and the model solved. We can see the mushrooms over here again. The server just handled with 2 clients, and we can go to the exit safely. When we will hit the help me button again, let's close this like this. All the closing is very good, no thread left behind. Over here we will hit the help me button again. Let's go back to the game. We will hit the help me button again, and we will see over here that we just made a solution for memory print on the screen that show us that solution that we pull again, we will come, actually the server will not solve again the maze, it will take it from the memory. We just store the solution in a zip file over here, you can see it, and let's push it again. Model solved. You can see over, give me a second, over here, this is the first one, the solution is over here, you can see it, okay, using BFS, attention, using BFS. Over here you can see the solution from the memory, it's the same solution as above, but this is from the memory, this is actually solving by the server. Okay, exit these two, and let's close the client. The client is closed, and we can close the server. Okay, this is our design, the design of our project. Our project is using MVP. MVP is a user interface, architectural pattern, engineered. Over here we can see the model. This is the interface of the model. This is the implementation of the model, the presenter, and the view. The model is actually an interface defining the data to be displayed or otherwise acted upon in the user interface. The view over here is a passive interface that displays data from the model and routes user commands to the presenter to act upon the data. The presenter acts upon the model and the view. It retrieves data from repositories and formats it for display in the view. Okay, now we will see the server side. The design pattern of the server is also MVP. You can see over here that we have a presenter, a view, a model over here. Okay, this is our main loop, okay, that waits for a client. When a new client arrives, we open a new thread over here and we solve his problem, okay. He actually sent over here, this is the method that solves the problem. He sent us sorry, over here. This is the method that actually solved the maze. The client sent us the maze and the algorithm that he wants to solve with, and over here there is a switch case that choose the algorithm, BFS, Manhattan A star or Euclidean A star, and actually solve the maze. Over here we send it back to the client. This is the over here we actually play this method and catch it over here. We write the object, the solution, to the client over here, output write object. Now we will go to the client to see where he catch it over here. Over here we can see the solving on the client side, okay. This is just again the name of the maze, the algorithm. Over here we get the maze from the hash map that contain the maze. We send it, we send the property, and over here we can see the query that we sent to the server with the IP of the server, with the port, with the maze, this maze, and the generator that is actually the algorithm. Over here, this is the query. This is all of this is the query. We read the object from the server, okay, and actually display it on the screen. We can see it over here, and this is it. We return a result to the server, to the client over here, the solution, and we will notify the presenter over here.
Okay, that's it. Hope you enjoy it. You can see our source code on GitHub. The link is attached down here. And that's it. Goodbye.